Hey guys, it's Mr. Sanchez here coming at you guys with a new lesson for Algebra 1. We're going to continue our lesson on slope. So we're in lesson 9-2, slope and rate of change. This is going to be a lot of writing for you guys, just FYI, but and it's only going to be one example today, but hopefully by the time we see more and more examples in class, we'll be able to write a function, okay? We'll be better at writing functions, right? Our learning targets for today are to calculate and interpret rate of change for a function and understand the connection between rate of change and slope. All right. All right. So before we begin, you guys are probably wondering what is rate of change. So I have the definition written down right here. And rate of change is what we call the ratio of change in y, the independent, also known as the dependent variable, to the change in x. Now, if you remember that what change in y is, we're basically saying change. Let me write this down real quick. We're basically saying change in y over change in x. You know what's the same thing as that? The rise over the run. It's also the same thing as delta y over delta x, which is the same thing as y2 minus y1 over x2 minus x1. And you know what? All of this is the same as slope. All we're saying is that the rate of change is basically slope. All right. The only difference is that where we used to have just numbers, rate of change, the slope now has units. So instead of just saying 5/3, you're gonna say or like let's say your slope is 2. Instead of it just being 2, it's gonna be like 2 miles per hour. So you ran 2. Your change would be 2 miles over 1 hour. So 2 miles per hour. All right, let's just go into our first example, and hopefully we'll get into the hang of things. If you need more, we need more examples. Once again, we're gonna go over more examples in class. This is just an example to get you into the idea of what we're doing. Okay. So let's look at this first example. All right, this, and I want you guys to write all of this down. I already wrote it beforehand just to make this video a little bit shorter, so we're not wasting time writing stuff. All right, so example 1, it says Ash went to the store to buy Pokeballs, right? So he likes buying you need Pokeballs to catch Pokemon, and each Pokeball costs $3. All right, the first question it's gonna ask us is this: write a function f of x for the total cost of Pokeballs if Ash buys X amount of Pokeballs. Okay, so we're right here right now. We're right here. And if you look at the information that they gave us, each Pokeball just costs $3. So let me write this on the side. Let's say I buy one Pokeball. One Pokeball is the same thing as $3, right? Two Pokeballs is the same thing as $6. Three Pokeballs is the same thing as $9, right? So how do we get these numbers? Well, it's really easy. It's 3 times 1, 3 times 2, 3 times 3. And if I want to know how much does 4 Pokeballs cost, right? That's going to be 12. How do we get that 12? It's going to be 3 times 4, right? So our function f of x is when you buy X amount of Pokeballs, right? So we don't know how many Pokeballs we're gonna buy, but we do know we need to write a function and we need to call it f of x. So let's start there, right? So we're gonna start with f of x is equal to something, and what does it represent? The total cost, how much it costs to buy a Pokeball. All right. So if you look at this section here, we're always gonna be multiplying the price times the number of Pokeballs, right? So let's do that. Let's write that. We're gonna write the price, which is $3. Oops. Let me get stuff like that. The price of the Pokeball, which is $3, times, and then how many Pokeballs are we buying? We're buying X amount, right? So we don't really know. We're just putting a placeholder variable, right? So it's going to be 3 times X. And that's it. That's going to be our function. All right, it's pretty simple. If you're buying X amount of Pokeballs, the cost is going to be X, 3 times X, right? So if you buy 4 Pokeballs, it's going to be 3 times 4. If you buy 10 Pokeballs, it's going to be 10 times 3, right? It's all the same. Now the next part of the question says make an input-output table of ordered pairs and then graph the function. All right, so here's our input-output pair, right? So what happens when we buy 0 Pokeballs, right? We can show that right here real quick. So it's going to be f of 0, which is the same thing as 3 times 0, or in other words, 0, right? So if you buy no Pokeballs, you don't have to pay anything, right? And then just separate those by line. And you guys might have to take a while to copy this down, and I apologize, but um, yeah. And if it feels a little bit crowded in my notes today, I was writing a little bit too big when I was setting it up, but it's the same thing. All right. So how much does 1 Pokeball cost? That's going to be f of 1, which is equal to 3 times 1, which is the same thing as buying 3 Pokeballs costs you $3. 1 Pokeball costs you $3. How much does buying 2 Pokeballs cost? Well, let's plug that into our function. F of 2 is going to equal to 3 times 2, which is 6. And then if you keep following it, what happens if you buy 3 Pokeballs? That's 3 times 3, which is 9, right? And then if you buy 4, that's going to be 12 Pokeball, $12. And then you buy 5 Pokeballs, it's going to cost you $15, right? This is all in money, by the way. Money, 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 money. So the number of Pokeballs gives, depending on the amount of balls you buy, then the price is going to be different. All right. All right, and now it says graph the function. So all you gotta do is plot these ordered pairs, okay? And in my graph, there's not gonna be enough room, but to graph everything, we're just gonna graph the first 3. All right, so we look at our first order pair at 0, 0. So we're gonna go over to our graph and plot 0, 0. 0, 0 is gonna be right here at the origin, right? Then if you look at our next point, it's gonna be 1, 3. So at 1, 1, 3, right? And then our next point is gonna be 2, 6, right? So we're gonna plot it at 2, 6, 2, 6. And then our next point is gonna be 3, 9. All right. So 3, 9. And I would keep drawing it, but if I don't have enough space, okay? So, don't worry about the specifics too much. Right, and this is gonna be our line. Right, this is how I'm gonna compare. It says to graph it as a line, by the way. So yeah. All right. So this is our rate of change. And we know to graph this because right here we have the number of Pokeballs, right? That's our independent variable, right? The x-axis always has the independent variable. And our y-axis, our total cost in dollars is going to be our dependent variable. And all these things mean is that the independent variable, you say what it is, and that's what it is. The dependent variable, in this case, f of x or y, all it's saying is that this number depends on what our x is. Our y depends on our x. That's all we're saying. And then the last question of this line is, what is this part is, what is the slope of the line we just graphed, right? So let's look at this graph. Let's find our slope. We can do point slope form. I mean slope intercept. No, I'm sorry. I'm gonna jump ahead of it. We can use the slope formula using 2 points like this. Well, we can also just do it this way, right? And then let's just do it the rise over run, right? So if we look here, we're gonna go 1, 2, 3. So our rise is 3, right? But what is it? Is it just 3? Or is it, remember, this now has value, so it's $3, right? So we're gonna write $3, right? And our run is gonna be, let's see what our run is gonna be. It's gonna be just 1. But is it just 1? No, if you look at here, it's gonna be number of Pokeballs. So it's one Pokeball, right? So when you write your slope, it's 3/1. So it's $3 over Pokeballs, right? Which is just three. It's $3, right? So per Pokeball. And you can just write that like this. You would write that $3 per Pokeball. Okay, and why do I write dollars per Pokeball? This we always put the number, the one on top first, right? And then per is like our divisions, our fraction, and then the new denominator goes here. That's basically what we did. So our slope is $3 per Pokeball, or our slope M is equal to 3, and then dollars per Pokeball. I'm just gonna write per Pokeball like this. Okay, and we're gonna go on to our next slide, which is kind of an interesting one. And then remember our slope is $3 per Pokeball. The reason it matters that we say dollars per Pokeball is because when we're looking at slope as rate of change, um, we're looking. Oops, sorry about that, guys. Sorry about that. Let me turn that off. When we're looking at dollars per slope as a rate of change, we actually need to see what's changing and why it's changing. And here it's changing. You can tell if we look over here, it's changing. Every time you buy a Pokeball, your price is changing, right? And then by how much does the cost increase for each additional Pokeball? Well, we kind of said that right here, right? The price increases by $3 for every Pokeball. So what we say is our rate of change is equal to our slope, right? But the only thing, so right here is going to be $3 per Pokeball. And remember, we got this because our slope was 3/1, and right here was dollars over Pokeballs. And this part is what turns into this part. And that's the difference between just slope and rate of change. Slope just gives you the number. So slope, I guess our slope would be this, but the rate of change would tell us like what the units are. You know, before it was just units, but now if you look at our graph, the X and Y axis are going to be labeled from now on. And it's going to tell you cost in dollars and why it's increasing, right? Or decreasing, right? And then if you look at this graph, we know that the slope is positive because the price is increasing. You buy more Pokeballs, the price is gonna go up, right? So if the price is going up, you know that the slope is positive. If our graph were to go like this, that means there's some sort of discount, right? The price would be decreasing, but that doesn't make sense when you're buying things. If the more you add, the more you pay. All right. All right, and that's basically it, guys. We're gonna have way more examples in class, and hopefully you'll start getting the hang of it. I made this problem up. Hopefully it makes sense to you guys. Other than that, guys, have a great day. I'll see you guys. If you need help, make sure to show up to the Zooms and ask questions in class. Bye bye.